Welcome to a short demonstration of Jmeter running on my local Windows 11 laptop. Although Jmeter load tests are typically performed with minimal graphical user interface (GUI), in this demonstration, we'll use more GUI elements than recommended to make the presentation extremely visible and clear. Keep in mind that when running load tests in the cloud or on a robust Linux host, we won't have as much real-time graphical presentation online. However, we can still generate all the desired graphics offline. Following the successful completion of the Jmeter load test, we'll have a wealth of graphical data. During this demonstration, we'll observe 30 concurrent bots running in a banking application. These bots will perform actions such as logging into accounts, checking personal balances, initiating money transfers, and even receiving alerts. The loop will continue until the specified time is up. Let's dive into the demo. On the Ultimate Thread Group screen, observe the vertical axis representing the number of threads. While it appears to indicate threads, it actually represents the number of bots. Each bot corresponds to a Java process thread. The horizontal axis represents elapsed time. In this demonstration, we've planned for approximately 5 minutes. At the center of the graph, you'll see 30 bots running concurrently within the banking application. On the aggregate report screen, you'll find a collection of statistics gathered during the test. These statistics run concurrently with the actual load test. Each label represents a specific transaction or action that both bots perform in every iteration. During each run, the bots perform tasks such as logging in, checking balances, initiating direct debit orders, making payments, and then logging out. The samples column displays the total number of times each transaction occurred. Pay attention to the average column, which indicates the average time taken for each transaction. This measurement is in milliseconds. Additionally, consider the median, 90th percentile, 95th percentile, and 99th percentile. Track the minimum and maximum transaction times as well. Lastly, focus on the error rate during our synthetic demonstration. Currently, there are 0 errors. While the active threads over time graph displays the ongoing execution of our test scenario according to the original plan, we can observe that the third group of 10 bots has already entered the bank. The server hits per second metric appears somewhat noisy. To enhance clarity, consider limiting the number of data points displayed to 50. This adjustment will help smooth the line and make it more visually clear. Keep in mind that each bot request hits the server, and with 30 bots running concurrently, we can expect over 30 server hits per second. The response times distribution graph provides a quick overview of our bot behavior. On the horizontal axis, we see the response time for each transaction. Notably, the red login operations take longer than the green logout actions, which is expected. However, there's a performance issue with the brown payments. These transactions are taking over 8 seconds to complete. Interestingly, direct debit transactions, which are typically slower, are actually much faster in comparison. The balance check operation appears sufficiently fast at first glance. The vertical axis represents the number of times each transaction has occurred. Finally, we can conclude that there is a performance issue with the payments transaction at this stage. Its response time is the worst compared to other relevant transactions. Further investigation is needed.